today that'll be the simplest of all concepts we have here. It's really child's play. That's what I want to start out with.
Oh.
Class, complicated motion or simple motion? Simple motion or complicated motion? Simple motion. Simple motion or complicated motion? Complicated motion. Okay, so now Budge. This is the only bear who ever took a karate course. He just earned his red belt. Thank you, Lorena. Thank you, class, also. Now, when you look at the motion of the red dot, how does it compare with the motion of the ball? Similar. Is it complicated? Which one is more complicated, the motion of the red dot or the motion of the bear? The bear is more complicated. There's something simple about the red dot. It's hard to see. Why? Because the wobble, 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 as the bear moves over, it also turns, and that obscures the motion. So in order to eliminate all that wobble, we're going to take a little trick. Simplify. So first, I'll throw this cardboard. It has an odd shape, and it has two dots, a green dot and a red dot. There are circles around the green dot, concentric circles. Now I'll throw it upward, and you look what happens. Just throw upward straight. Now, how is the motion? What's your first impression? Simple or complicated? When you look at the circles, look again. Simple or complicated? Simple, complicated. The complicated have it. Now, I'll turn that cardboard around, and it has only the red dot. Now this time, the circles are around the red dot. Now throw upward, new bud. How is the motion now? Simple or complicated? Simple? The simple has it. So it must be obvious, must be very clear. Now, there's something special about that red dot. Watch me. I'll put my thumb right at the red dot, now support it. I can balance. So there's something special with that red dot. It's called the center of mass, okay? And that has amazingly simple properties, although there may be a lot of complication around, a lot of wobble, but when it comes to the center of mass, things become simple. Become simple motion. In every object, every body has a center of mass. I'll show many of them as we go along. By the way, today's lecture and the next lecture, they form a bridge. So next time we apply the concept of center of mass also for stability. So that's a concept that the engineers use, the architects to build houses and bridges to keep things stable. So now back to the wobble of the bear that makes the motion so complicated. I have a baton here, and this baton has 3 little lamps in it. A red lamp, and a yellow lamp, and a green lamp. I turn the lights down so that we can see the lamps better. So there's a yellow lamp on the side, there's a red lamp, and a green lamp. And watch that. I can balance the baton with my finger right under the red dot. What could be at the red dot? Center of mass. Center of mass. Okay, so that's where we put the red dot and the red lamp. And the two other lamps, on purpose, they are not at the same distance. So the green one is a little bit further out than the red one. I'll turn the lights on a bit more. So again, at the center of mass is the red lamp. That's where I'm supporting it, so it's stable. And there's a yellow lamp and a green lamp. What I did, I'm not going to throw it here so I don't injure anything, but at the time I went to the satellite union and I threw this baton real high so that it flew over in an arc and at the same time turned just like the teddy bear. And we turned all the pictures out, put a towel under the crack of the door so that it was pitch dark. So that was 25 years ago. And with the edge of the technology at that time, we took the following picture that I'll show now. So again, I'll make a better contrast. I'll turn all lights off to have the best contrast. That's when the baton left my hand, and shortly after it left my hand, and the camera shutter opened, and then we see the camera took this picture in long time exposure. So the camera lens was open, the shutter was open all the time. And I want to show now by overlay a little bit what happened. So here I made an overlay of the baton. So at that time the camera opened, and then as it rose it also turned. So I tried to act that out here. Okay, that's a yellow. It's a little bit faint. Okay, so the turning is always at the same rate, but when it rises, it gets slower. That causes that particular figure. So now it rises only very slowly. That causes that horn. And at the top, so that's the highest position right here. And it turns around and so on, swirls around. So we have a turning combined with projectile motion. And there's one point of the baton that shows only projectile motion. Which one is that? That's the point that turns around itself. That's the center of mass, that's where the red lamp is. So it just so happened that it landed flat, the way I'm acting it out, it landed flat on the floor and bounced straight up and over. So here we see three parabola parallel to each other, and that's where the camera closed. So I will post the same picture on the bulletin board. It was on the cover of a national magazine at the time. So, but that shows very nicely the concept of center of mass. So there's all these three curves, they look beautiful, they have their own aesthetic and beauty, but one is very simple. Which one is that? Which color? You tell me. The red one. That's the center of mass. So there's something very simple about the center of mass, shown here, that shows only projectile motion, and the other show projectile motion with rotation around it. And so that's what we saw with a teddy bear, and more clearly with a baton. At that time I balanced it for a long time to have it exactly at the center of mass by balancing something the way I'm doing it here. It took me several minutes to balance it, exactly, so I'm only indicating. Yeah, one needs to be patient, but once it balances, we're almost there. So that's how the center of mass was figured out of this baton. We're supposed to keep our environment clean. But the old days, when there was less concern about the environment, people tossed a bottle out of a car window, and then the bottle falls in a complicated motion, flies over, and there's one point of the bottle that moves in a simple motion. Which point could that be? Center of mass. Okay, so here with that bottle, I mark the center of mass. It's inside, where the red dot is. Let's check. Can I balance it? Yes, right here. So it must be the center of mass. Balance it from the other side. So as long as the finger is beneath, it'll always balance. So that's one method to find the center of mass. There are two methods. One is the support method that I already showed with a bottle and the cardboard. There's another one that I'll introduce in a moment.